Hi, welcome back. This is Mr. Hopkins here again. This is Honors Algebra 2, and today we're going to take a look at 11-2 Arithmetic Series, not sequences, series. The main ideas here are we're going to try to find the sum of the arithmetic series, and we're going to use sigma notation. Yes, that's sigma as in the Greek letter sigma. Some new vocab we're going to look at: series, arithmetic series, sigma notation, and index of summation. So to start things off, let's talk about a real-world situation. Amphitheaters. This is an example of an amphitheater in Austin, Texas. Let's suppose we have an amphitheater that in the first row we can seat 18 people. Now, each row behind there is a little bit bigger than the one that sits in the front because of the way the amphitheater is shaped. If that's the case, let's say that 4 people more could sit behind row number 1. 4 people more than that could sit behind row number 2, so on and so forth. So what that means, in row number 1 we have 18 people. In row number 2 we would have 22 people. Row number 3, 26 people, so on and so forth. If I am the owner of this amphitheater, I would like to know how many people can I actually fit into this amphitheater when it comes time to sell tickets. So one of the questions I might ask myself is, hey, the first 4 rows, that's where the expensive seats are. How many people can I sell tickets to? So what I want to know is, if I'm selling tickets, how many people can sit in the first 4 rows? And that would simply be a matter of adding the number of each row. So row 1 we said could fit 18, row 2 could fit 22, row 3 could sit 26, and row 3 could sit 30. Add all them up, that gives you a total of 96. This is what we call a series. And a series, as you can say here, is an indicated sum of the terms of a sequence. So the numbers 18, 22, 26, and 30, they are terms of a sequence. However, when I take terms of a sequence and I add them together, that is when I get an arithmetic series. To denote an arithmetic series, we use the representation S sub n, and this represents the sum of the first n terms of any given series. So for example, S sub 4 would be the first 4 terms of that particular series, or in this case 18 plus 22 plus 26 plus 30. As always, we're looking for a shortcut. There's no way I want to sit down and I want to add up every single row of the entire series to figure out how many people can sit in my amphitheater. So the question is, what is the shortcut? Well, the shortcut is given by this equation here, the sum of the arithmetic series. It says the sum S sub n of the first n terms of an arithmetic series is given by S sub n equals n over 2 times your sequence formula, 2 times a sub 1 plus n minus 1 times d. I suggest you remember the second part of this equation. This is usually the one students have an easier time remembering. So the sum of an arithmetic series is given by the equation S sub n equal to n over 2 times the quantity of a sub 1 plus a sub n. A sub 1 denotes the first term of your sequence. A sub n denotes the last term of your sequence. N represents the number of terms that you're looking for, and S sub n represents the sum of the first n terms. So let's give this a try. First question, let's try to find the sum of the first 20 even numbers beginning with 2. So first thing, I'm looking for S sub n of n over 2 times a sub 1 plus a sub n. If I'm looking for the first 20 even numbers, that means n is going to be represented by 20 because that's the number of terms I'm searching for. So I have a 20 divided by 2 times the quantity a sub 1, which is the first term. So the problem tells me we're beginning with 2, so a sub 1 will be 2 plus a sub n. Now is when I have to do a little bit of work. I want the last term. The way I find the last term is I use the sequence from 11.1. So I know from 11.1 that a sub n is equal to a1 plus n minus 1 times your common difference. So I want the 20th term here. So the 20th term can be defined as a sub 1, or the first term, which is 2, plus n minus 1, so 20 minus 1, times my common difference. My common difference here, since we're talking about even numbers, would be 2, because I would go from 2 to 4 to 6 to 8, so that makes the common difference 2. Solving this equation would give me the 20th term. So this gives me a 20 minus 1, or 19, times 2 plus 2, which makes the 20th term 40. This is a sub n, the last term that I'm trying to add together. So the first 20 even terms start at 2, end at 20. So together, the first 20 terms, first 20 even numbers added together are 40 plus 2 times 20 divided by 2, or 420. Let's try a real world situation here. A radio station is giving away money every day in the month of September for a total of $124,000. They plan to increase the amount of money given away by $100 each day. How much did they give away on the first day of September, rounded to the nearest cent? So this one's a little bit tougher. We first have to start off by finding out how many days there actually are in September. For those of you who don't know, that would be 30. So, 30 total days in September. That represents the number of terms I'm trying to add together. So, if we go to our equation, the sum of n has to equal n over 2 times a sub 1 plus a sub n. Now, what else do I know from this problem? Well, I know there's been a total of $124,000 given away for the month of September. So guess what? That has to be your sum. So 124,000 is the sum, and this happens after 30 days in September divided by 2 times a sub 1 plus a sub n. Now, they plan to increase the amount by $100 each day. How much should be given away on the first day of September, rounded to the nearest cent? So here I have a little bit of trouble because I don't know the first term, and I don't know the last term. That gives me some trouble. But what I do know is I know that a sub n has to equal a sub 1 plus n minus 1 times d. Now, because I know a sub n equals a sub 1 plus n minus 1 times d, I can take this entire thing and put this right in there for a sub n. That gives me a sub 1 plus all of this. So together that is 2 times a sub 1 plus n, which I now know is 30, keep in mind, for 30 days in September, minus 1, times my common difference, which, guess what, they told me they were giving away $100 each day, so that common difference must be 100. Now that I have everything plugged in, we can do a little bit of simplifying. So, 124,000 equals 15, 2 times a sub 1 plus 29 times 100, which is 2,900. And I can continue to solve for a sub 1. Now, because I'm running out a little bit of room here, and I don't write the best with a mouse, I'm just going to go ahead and talk our way through the steps. So we're taking 124,000. We're going to first divide by 15 to bring this over on the other side. I'm then going to subtract off 2,900. And finally, we're going to divide by 2. And that will give me a sub 1, which is a value of 2,683.33. All right, so moving from radio stations and a large amount of money that they give away, back to regular numbers. So let's find the first 4 terms of an arithmetic series in which a sub 1 is 14, a sub n is 29, and s sub n is 129. These types of problems we like because just follow the formula. So I'm looking for the first 4 terms, and I know this given situation. Well, if a sub 1 is 14 and a sub 9 is 29 and s sub n is 129, what I can do is I can figure out how many terms separate 1 and 29. So we can say s sub n is equal to n over 2 times a sub 1 plus a sub n. Solving for n in this case, and again we're going to talk our way through these steps because my mouse handwriting seems to be getting worse as we go on. We're going to go 129 times the 2, which is going to give me 258. 14 plus 25 is going to be a 39, which I can then divide by, and that gives me an answer of 6.6. Oops, I'm sorry. That doesn't seem right. I couldn't read my handwriting. This is what I was talking about. The 25 that I talked about appears to be a 29, not a 25. So let's back up a step. I'll fix my handwriting. Much better, 29. So let's go 129 times the 2 as I bring it over, which is a 258. 14 plus 29 is now a 43. Which if I divide by that 43 gives me n equal to 6. That looks a little bit better, a little more reasonable. Now, what this now tells me is since n is 6, that means the 6th term has to equal 29. And if the 6th term has to equal 29, I can go back to what I know about sequences, and I can say a sub n, in this case a sub 6, has to equal a sub 1, 14, plus n minus 1, 6 minus 1, times my common difference d. Now, I have no idea what d is. That's what I'm looking for because I need to find these first 4 terms. But what I do know is this a sub 6 is actually 29. Now, solving for d means I can go 29 minus the 14 to the other side, which gives me a 15. 6 minus 1 is 5. Divide by 5 means d has to equal 3. Once I know that common difference is 3, I can now start at a sub 1 and define the first 4 terms. Term 1, 14. Term 2, 17. Term 3, 20. Term 4, 23. Now, keep in mind we're not just looking for terms. They want us to give an arithmetic series, which means this should be 14 plus 17 plus 20 plus 23. And that is the first 4 terms of our series. Okay, last thing for today we're going to cover sigma notation. Sigma notation is the ability to write out a series without the long, drawn-out plus, 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 plus. This is expressed using the Greek letter sigma. So, for instance, the series 3 plus 6 plus 9 plus 12 plus so on and so forth, all the way up to 30, can actually be expressed as 3 times n from 1 to 10. This sigma stands for sum. So this means find the sum of all the numbers created by 3n from 1 to 10. This is read as the sum of 3n as n goes from 1 to 10. 1 is the first value of n that gets plugged in. 10 is the last value that gets plugged in. And this represents the series that we found. N is what is called the index of summation. The way you calculate this is you simply take the number 1, you plug it in, you get 3. Then you take 2, you plug it in, and you get 6. And you do this for every integer until the last value of n. You then add all these numbers together, and that is your sum. So, let's try to evaluate the sum of 2k plus 1 from 3 to 10. This should simply be, take the numbers, plug them in, and see what happens. So, we start with this number down here, which is 3. I take 3, I plug it in for k, I see what I get out. 2 times 3 gives me 6, plus 1 more gives me 7. Sum for sigma means plus. So I go plus, and I plug in the next integer in line. Next integer in line has to be 4. So 2 times 4 is 8, plus 1 more is 9. Then I plug in 5. 2 times 5 plus 1 is 11. Then I plug in 6. 2 times 6 plus 1 is 13. And this pattern would continue until I hit the very final number. That final number is whenever I get to 10. So 2 times 10 is 20, plus 1 is 21. This marks the end of my series. Once I get here, I then plug in all of these numbers, add them all up, and together they equal 112. That's how a sigma notation sum series is calculated. So let's try another one. I have 2i plus 3. So again, 5 is where I start, 10 is where I end. So I start with 5. 2 times 5 is 10, plus 3 gives me 13. Sum means I add. So now I plug in 6. 2 times 6 is 12, plus 3 is 15. Now I plug in 7. 2 times 7 is 14, plus 3 is 17. 19. 21. 23. Again, I notice stop because my last number is 10. When I plug in 10, 2 times 10 is 20, plus 3 gives me 23. Adding all these numbers together give us a grand total of 108. That's it for today's lesson. So before tomorrow's class, when we do some more practice of this, I would like you to try the following. You have 4 problems to do, and as before, the answers are highlighted over here in yellow. Please try the problems. Don't just look at the answers and say you did the homework. Try the problems to make sure you are actually getting the correct answers that we're looking for here. Tomorrow in class, bring in any questions that you have about these 4 problems and or any questions that you have about today's lesson. And we'll see you tomorrow.